Good morning all. Here's a Moog brushless servo motor. And it is type FAST-0-M2-030-00-02-00. Now, I don't have the pinouts on this resolver, but that's not a problem. I'll show you all how I figure out the pinouts of the resolver on this connector right here. And then afterwards, we'll hook that resolver up and we'll test it. I'm going to remove this cover so we can see which pins on that connector are being used. We can look at the back of the connector and see which pins are being used. Here's the connector. There's quite a few pins, but they're not all used. 2 pins will be used for the motor thermal. 2 pins will be used for the excitation of the resolver. 2 pins will be used for the sine of the resolver. And lastly, 2 pins will be used for the cosine of the resolver. And we can look down in here and see those pins and wire connections. Let's get our meter into play, and we're going to measure the resistance of those connections. But first, let me draw a diagram of our connector. Skip a line. There we go. And up here is the keyway. So here's A, B, C, D, E, F, G, H, J, K, L, M, N, P, R, S, T, and U. Now notice that I and O are not part of this pinout. The reason being is because an I looks like a 1 and an O looks like a 0. So they leave that off of the lettering of this connector. Okay, get something to stand this up on. We'll use these 2 blocks of wood right here. And these 2 blocks of wood so I can stand that motor up. Don't drop it on the floor. Probably shatter those magnets inside that drive. Can I move over? It's going to be hard to get everybody in the picture here. There we go. I need to get that paper in the picture. We're going to write down the ohmic values of our pinouts. Now first let's find the motor thermal. It's going to be those two blue wires. Looks like A is one of them. We have 178.6 ohms right there. Did y'all see that? Get this down here where I can see it. Move that over. Okay, I don't want to get in y'all's way. 178.6 ohms for the motor thermal, and that's A and N, it looks like. So over here, I'm going to back that camera up a little bit so y'all can see. There's A and N. We had 170. Let's do it again. 178.6 ohms for the motor thermal. Okay, now let's try to find the resolver pinouts. Okay, there's a two wires here. Let's try those. Okay, there's 69 ohms on B and D. Let's write that down. .0 ohms. Now we don't know yet if that's excitation or sine or cosine. But the excitation resistance will be different from the sine and cosine. And the sine and the cosine will be very close to equal in resistance. So we need to find the sine and the cosine. There's two wires down in there. Okay. Let's go to C. We know B and D is 69 ohms. All right. There looks like A, B, C, D, and E. C and E is 39.8 ohms. Let's write that down. C and E are 39.8 ohms. Now, we need to find the last two pins and measure their ohmic values. Let's see if it's G and H. We have A, B, C, D, E. Let's try F. We don't have F yet, do we? No. That's my fingers. There, I saw it. It looks like G and H are 39.4 ohms. 39.4 ohms for G and H. Now that's the only wires used. All of these other wires are not used. So A and N is 178.6 ohms. That's the motor thermal. B and D is 69.0 ohms. That is the excitation input to the resolver winding. We know that because on C and E we have 39.8 ohms and G and H is 39.4 ohms. Those will be the sine and the cosine. And the odd one out, the different one, is the excitation. Let's move this out of the way here. And we have A, B, C, D, E. And F is not used. I'm going to X that one out. G and H are used. This is not used. A, B, C, D, E, F, G, H, J, K, L, M, N, P, R, S. Modify my drawing. I skipped a pin. T, U, V. Okay. I thought I saw a wire. It could be the frame ground. It's a white wire I see on the back of that connector. Let's see if we can determine who that one is. Yes, okay, that is, there's R, looks like S is frame ground. A, B, C, D, E, F, G, H, J, K, L, M, N, P, R, S. Yes, S is frame ground. Let's write that down. S is F, G, frame ground. And T is not used. Now, let's set up this circuit to test that resolver. I'm going to use this function generator set to 10 kilohertz frequency, a sine wave of 10 kilohertz at 10 volts peak to peak, and that will be the excitation sine wave for the resolver. So let's get over here, set up our function generator. 10 kilohertz on the dial, and 10 volts peak to peak. I've got these socket pins that are going to allow us to connect to that connector right there. Let me sit down. We got our diagram. Let's hook up the excitation first. That was B and D. So here's A, B. C and D. There's B and D. We'll put the positive of the function generator on B, and we'll put the ground on D. Now, for the sine and the cosine. We don't know who is who, but it doesn't matter, because we will be able to see both the sine and the cosine, unknown which is which, on the oscilloscope. So there is pin C, and here's pin E. Some jumper wires down here. And we're going to connect the oscilloscope ground to pin E. And we're going to connect C to channel 1 oscilloscope probe. Now the next is G and H. So we're going to go down here, connect our wires to G and H pins. We're going to connect oscilloscope ground to H. Whoops, H fell out. Get back in there, H. There's pin H to oscilloscope ground, and pin G to channel 2 scope probe. And I like to set the oscilloscope to chop mode. Let's see what we get. Okay, let's turn the amplitude up a little bit. There we get. Now we don't know who's who, but we have good waveforms. Crank the amplitude up just a little bit more. That way they'll trigger on each other, and one form or the other won't be blurry. Let's move this one down just a little bit. There we go. Let's bring that up. So they overlap a little bit. It kind of untriggers itself. Let's move that up a little bit more. There we go. I think that's the best we're going to be. Okay. Let's get close to that oscilloscope and y'all can see what's going on. I love working on resolvers. It's amazing how you can set these things up and actually see them work. Here are the two waveforms generated from the resolver. Now, you can see that both waveforms are about the same amplitude and we're in phase. I'm going to rotate the shaft of the resolver. Now, the sine is at max and the cosine is at minimum. Continuing to rotate. Now we're out of phase, about the same amplitude, but out of phase. The sine is going to minimum and the cosine is going to max. We're in phase again, same amplitude. Let's trigger on channel 1. Same amplitude but out of phase. Let's trigger on channel 2. In phase. I wish I had a scope that would automatically trigger on whichever one had the most amplitude. That way the screen wouldn't blank out. Let's go to XY mode. In XY mode, you can see a waveform that rotates clockwise or counterclockwise, depending on which direction I rotate the shaft of that motor. So here I'm moving clockwise and the waveform is rolling clockwise. And now I'm moving the shaft of the motor counterclockwise and the waveform is moving counterclockwise. Isn't that fascinating? Fascinating. Well, there we go. That resolver is good. Now we know how to hook up and test a resolver of unknown pinouts based on the resistance of the coil windings of that resolver. All right, all. Thank you very much for stopping by and watch us test that unknown resolver. Hope y'all's having a good day. We'll see you next time.